Hello friends. So in this video we will see another important problem, that is from joint density function how to find the marginal distribution of x and marginal distribution of y. So in the given problem the density function is given, and first we have to find the value of c. So the given density function fxy of x comma y is simply c for 8.5 less than or equal to x less than or equal to 10.5, and y range is 120 less than or equal to y less than or equal to 240. We know the property of the density function, which every density function, whether it is a normal density function or joint density function, area under the density curve should be 1. So here it is joint density function, that is why minus infinity to infinity fxy of x comma y, fxy of x comma y dx dy should be equal to 1. So this is nothing but area property of the density function. Area property of PDF, whether it is PDF or joint PDF, this has to be satisfied. So here it is given, instead of minus infinity to infinity we have to take the limits for x and y. So lower limit of x is 8.5 to 10.5, and integral y limits are 120 to 240, c into dx dy is equal to 1. So c is a constant, we can write outside and then 8.5 to 10.5 are the limits for x, so dx. So here we are separating the integration, and y limits are 120 to 240, dy is equal to 1. So integration of dx is simply x, limits are from 8.5 to 10.5, so there is a constant c outside, into integration of dy is simply y, limits are 120 to 240, that is equal to 1. So next, if we substitute the limits, so c into upper limit is 10.5 minus 8.5 into upper limit for y is 240 minus 120, that is equal to 1. So 10.5 into 8.5 is 2, and 240 minus 120 is 120, so that is equal to 1. So from this c is equal to 1 by 2 into 120 is 240. So what is the value for c? It is 1 by 240. So in order to find this, what we are using, simply we are using the area property of the density function. Area property of the density function, area property of the density function. So we have substituted the limits and we have separated the integration, and then we have simplified, we got c is equal to 140, c is equal to 140. Next bit, we have to find marginal distribution of x and marginal distribution of y. So the formula for marginal distribution of x from joint distribution of fxy is, if we are finding for x, so the limits will be minus infinity to upper limit should be x, and limits of y should be minus infinity to infinity fxy of x comma y dx dy. So this is the expression or formula for marginal distribution of x. So the lower limit, if you see, the lower limit of x is 8.5. So instead of minus infinity, we have to write the lower limit for x as 8.5, whereas limits of y is 122, 240, and fxy of x comma y is c. So that's we found we have 1 by 240 dx dy. So again 1 by 240 is a constant, so we can write outside 1 by 240 and then separate the limits of integration. For x it is 8.52x dx, and for y it is 122 240 dy. So it is the same integration what we have did while finding the constancy, but only for x limits are changed. So 1 by 240 into x, limits of x are 8.52x, and limits integration of dy is simply y. Limits of y are same, 120 into 240. Next we have to substitute the limits. 1 by 240 into upper limit is anyway x minus lower limit is 8.5 into upper limit for y is 240, lower limit for y is 120. So if we simplify, it is 1 by 240 into x minus 8.5, 1 by into 240 minus 120 is 120. So 0 0. So this will cancel 2 times. So this will be x minus 8.5 by 2. So fx of x, marginal distribution of x from the joint density function. So of course we have to write the limits of x here, and otherwise it is 0. Limits for x are 0 less than or equal to, sorry, 8.5. limits of x are 8.5 less than or equal to 10.5 and 0, otherwise 0. Otherwise we have to write the limits for x. So this is the marginal distribution of x from joint PDF. So what we have done, so this is the expression or formula for finding marginal distribution of x from the joint probability density function. If it is fx of x, the x limit should be minus infinity to x, while limits are minus infinity to infinity. Next we will find the marginal distribution of y. Marginal distribution of y. The expression is fy of y is, now y limits are minus infinity to y. While finding marginal distribution of x, the limits are minus infinity to x. Now if we are finding the marginal distribution of y, the upper limit of y should be y. X limits are minus infinity to infinity, fxy of x comma y dx dy. So this is the difference between marginal distribution of x expression, marginal distribution of x expression, and marginal distribution of y expression, marginal distribution of y expression. Now we will substitute the limits. We will substitute the limits. So fy of y is equal to, lower limit for y is 120. So instead of minus infinity, we have to write 120. X limits are 8.5 to 10.5. fxy is c, that is nothing but 1 by 240 dx dy. So rest of the procedure is same. We will separate the limits of integration. We have to write 1 by 240 outside. So 122 y dy, and limits of x are 8.5 to 10.5 dx. Now if we do the integration, it is simply 1 by 240 into y, limits of y are 122 y into integration of dx is x, limits are 8.5 to 10.5. Now substitute the limits. It is 1 by 240 into upper limit is y minus lower limit is 120 into upper limit for x is 10.5 minus lower limit is 8.5. So now if we subtract, it is y minus 120 by 240 into 10.5 minus 8.5 is 2. So this will cancel 120 times. So it will be fy of y is y minus 120 y minus 120 by 120. Now here we have to write the limits for y. Limits of y are 120 less than or equal to y less than or equal to 240, and it will be 0. It will be 0. Otherwise, it will be 0. Otherwise. So this is the expression for the joint distribution of y. Joint distribution of y. Joint distribution of y. So we have to remember one thing. The expression for marginal distribution for y, it is minus infinity to y. X limits are minus infinity to infinity. fxy of x comma y dx dy. So if it is the marginal distribution of x, so we have to write the upper limit for x as minus infinity to x. Y limits are minus infinity to infinity. fxy of x comma y dx dy. So this is the expression for marginal distribution of x. For finding the constant, we have to use the area property. So I hope everyone is able to understand this problem, how we have solved. So if you have any doubts, please enter your comments in the comment section. Thank you for watching the video. Subscribe to my channel, share with your friends and classmates. Thank you for watching.